What's up everyone? Welcome to our first video for Unit 9 where we're going to be talking about area and circumference of circles. So, some recap of definitions and concepts that you might have seen before. We have the radius of our circle, and this definition is it's a segment from the center of the circle to a point on the circle. So, here we have one example of a radius shown, but there are like infinitely many. I can draw a segment going this way from our center, from here to our center, from here and here and here and here. There are so many different radii that are present in the same circle, and they are all going to have the same exact length. Now, a diameter is a segment that connects 2 points on the circle, and it has to go through the center, right? So here we're connecting this point and this point on the circle, and we have to go through the center to get there. Now, a really, really important concept, and this is like you should highlight this, make it big, underline it, is that the diameter is double the radius, always. Now, we can also work backwards here, right? The radius is then half of the diameter. Now, something else, we have the area. The area is the shaded region inside, right? And it's area of a circle, so it's a shaded region inside of the circle, right? And it would look something like this. And then last but not least, we have the circumference of our circle. And the easiest way to put this is that it's the perimeter of the circle, right? So it's like the boundary of the circle, the outline of the circle. So if we highlighted that, it would look something like this. And you guys should do this too with markers or highlighters. You should be making the same markings in your notes so that you have it to refer to. Now, building on area and circumference, we have these two formulas. So the area is capital A, and it equals pi times r squared, where r is the radius. And then for circumference, we have C equals pi times diameter, and big C is for circumference, and D is diameter. Now, another way that we can think about this, we said that the diameter was twice the radius, right? So another way that you can write that formula, instead of writing pi times D, you can write C equals 2 pi r, and then when you do that, 2 times r, that would actually give you the diameter, right? So either, you might see the equation in either of those forms, so make sure you have both of those written down and that you know what each of those variables represent. Now, this is an easy way to remember the formulas. For circumference, we have cherry pie is delicious, right? C equals pi times D. And apple pies are 2. Now, how are we going to use area and circumference? Well, one, they could obviously ask you, they can give you the diameter or the radius and say, hey, find that area and the circumference, but that's kind of rare at this level. We're really going to be working with more examples, like if we're given the area, it might say, hey, find some other information about the circle, like find the radius or find the diameter from this area. And then the third one is working with area and circumference in real life situations. So the first example we'll do together is like example number 1. So they give us that the diameter of the circle is 6 feet. So before I make a list of what they give me, we have D equals 6, and it wants the circumference. So I'll write C equals question mark, right? Now I know the formula for circumference, so let's write that down. Cherry pies are delicious. C equals pi times diameter. Now, we already have our diameter, so all we need to do is substitute that value in. Our C is going to stay as C because that's what we are looking for, equals pi, and then our diameter in this case is 6. Now, if they had given us the radius instead, right, let's say this question said the radius of our circle is 3, we would have had to take that value and then have multiplied it by 2 to get our diameter, right? Or we could have used C equals 2 pi r and then substituted our radius in there. It's going to give you the same exact answer regardless. All right, now it says this should say on your notes, it says leave in terms of pi. Now what I like to do, I'll put that pi in front. Leave in terms of pi means that pi can stay in your answer. You don't have to go to your calculator and simplify it, because remember, pi is just a number. Pi is 3.1415, and it goes on and on and on. But if it says leave in terms of pi, it's totally okay to just write pi in your answer, and then you'd be done. Now, this question is going to go a little bit backwards. So this question says, a circle has an area of 25 pi square inches. So remember, this is just a question completion strategy. I make a list. A equals 25 pi square inches. And the first part is it wants to know the radius. So I put r equals question mark. And again, we see leave your answer in terms of pi, right? So we're dealing with area, so I'm going to write that formula out. A equals pi r squared. And I want to see, I have capital A right now. I have our area, so I'm going to go ahead and substitute that in. 25 pi equals pi r squared. Now what's interesting about this, and what's interesting about questions like this, is that you might have pi on both sides of the equation like this. And if you do, they would end up dividing and simplifying out. So if you see pi on both sides, you can just cross them both out. So then what we are left with is 25 equals r squared. And if we take our square root, we get that 5 equals our radius. Now we don't have to leave our answer in terms of pi here. There is no pi to be left. But now we have our radius. And remember, we started with the area, so this was us working a little bit backwards. Now, these questions can go a step further, and this one's saying, hey, now what's the circumference of the circle above? So now I have my radius from before, and now we're looking for C. We're looking for that circumference. So we have cherry pies are delicious. Our circumference is going to stay as C. We have pi, and then we need our diameter here. So remember, do not, if I just plugged in 5 or I substituted in 5, I would get the wrong answer. I need to multiply that by 2 to get that my diameter is 10. So C equals 10 pi. Now in this question, it says round your answer to the nearest tenth if necessary. Now it's not okay to leave pi in your answer. So what you would have to do is in your calculators, put in 10 and then put in the pi symbol. And if you do that, you're going to get C equals 31.416, but it says round to the nearest tenth. This will also keep going, but rounding to the nearest tenth, we get C equals 31.4 inches. Now this was nice and broken down for us. It first told us to find the radius, but that like midsection of the question might not always be there. It might give you the area and say, hey, find the circumference. So you have to recognize, okay, I know I need the diameter, and you can kind of like work backwards from there. You also could have done this, C equals 2 pi r, and then substituted in your radius and did 2 pi times 5, and again that would have left you with the same answer. All right, this is our third example where we are going to be using area and circumference in real life context, and the first thing you want to do with these is just ask yourself, is this an area question or is this a circumference/perimeter question? So we have a wheel has a radius of 5 feet, so we should be making our list here. We have r equals 5. And wants to know the minimum number of complete revolutions that the wheel must take to roll at least 1,000 feet. Now, first question, area or circumference? Well, if this was, we have a wheel, right? And sometimes you have to just think logically about this. This is our wheel, and that wheel is going to be rolling and doing some revolutions to travel a certain amount of feet. Now you have to think, does it matter the space that's inside of the wheel? Does it matter how much that shaded region is? Or does it matter the wheel's perimeter? Now, this question is going to be a circumference question, because what's happening is we have a wheel and it's going to just be rolling and rolling and rolling and rolling. Now we have a wheel that's starting, and it's going to do a certain number of revolutions, and our end goal is to get to 1,000 feet. So it doesn't really matter how much region is shaded inside, it matters the perimeter of that wheel. So I know I'm dealing with circumference here, so let's go ahead and just find that, right? So cherry pies are delicious, so our circumference is going to stay as C. we have pi, and then our diameter, we can figure it out. We have a radius of 5, so if we multiply that by 2, we get that our diameter is equal to 10. So here, we have the same exact thing from last time. Our circumference is still 10 pi. Now, the idea is this is 1 revolution. So if we put this in our calculator, it would be like 31 point something. That's how many feet we're going with 1 revolution. But we want to know how many revolutions do we need to complete in order to get 1,000 feet. So again, what this means is that with 1 revolution, if this wheel is spinning and ends up back with this point A at the bottom, we've went 10 pi feet, which is like 31.4 feet. So what we have to do actually is take that 1,000 feet and divide it by our circumference. So you can divide it by 31.4, but I don't want to round too early because rounding can mess up our answer. So I'm just going to divide it by 10 pi. That's our circumference. So if you go to your calculator and you hit the math button and you scroll all the way down to fraction and hit enter, you'll be able to type in your numerator and denominator. So you do 1,000, you hit the arrow, and you do 10, second, and this button will give you pi, and then you hit enter. So this is 31.831. Now what this number represents is the exact number of revolutions to get 1,000 feet. But a lot of times, you're not going to be able to go 0.83 of a revolution. That's not how things work with real-life context. So you have to round that number up. Because if you only go 31 revolutions, if you did 31 revolutions and you multiply that by your circumference, that would only give you 973 feet. So you have to round this number up. So your answer is going to be 32 revolutions. You want to make sure you are going that full 1,000 feet. Alright, so that's it for our first lesson. Again, don't forget we have this mnemonic to help us remember the formulas. And don't forget, you got to use your strategies. Make your lists of what's given to you. Figure out what you're looking for. And you might have to work through multiple steps for one problem, but you always got to start with your given information and build your story from there.